Welcome everyone. For today's prep, I want to look at one more implicit differentiation example. And this one's going to involve a little bit more. So we'll get a little more practice seeing how this process works. All right, so let's look at this equation. We have this equation 6x squared times y cubed minus 4x times y squared minus 5x is equal to 8. So we have this equation, and we want to calculate the derivative dy dx using this technique of implicit differentiation. So we have this equation, and it's not in the form y is equal to this. So we can't do kind of our regular differentiation. We have to use this special method, this implicit. All right, so what are we going to do? Well, the first step is just to go through and apply the derivative to each term in our equation. So anything separated by addition, subtraction, or an equal sign. So we got 4 terms here. And the idea is we're going to differentiate each of these. All right. So let's look at this first one. We want to calculate this derivative. And what do we have? Well, inside we've got, there's an x term and a y term, and we're multiplying. So when we're multiplying variables like this and we want to differentiate, we got to use product rule. So we're going to use product rule for this one. And if we look at the next one, well, there's also some x terms here, some y terms here, and then we're multiplying in the middle. So we're also going to use product rule for this one. So we got to do a little bit more with those two. What about the 5x? That one just has an x, so that one's not a big deal. And then the constant over here, also not a big deal. All right, so let's start with the first term. Let's do our product rule on that. So when we do product rule, first step is just to write down 2 copies of the product. So we'll have our 6x squared y cubed, and then our 6x squared y cubed. And in the first copy, we apply the derivative to the first part, so I'll include the 6 in there. And then in the second copy, we apply the derivative to the second part, so the y cubed. And with product rule, we get a plus sign in the middle. All right. So now let's go on to the next one. So let's do this 4xy squared. And we have this minus sign. And it's really easy to forget to distribute the minus sign when we're going to do product rule. So to help us remember, I'm going to include this minus sign with the 4. So let's write down, so this minus sign, we want to be careful with that. So let's include that with the 4. So we're going to write down 2 copies of our product here. So we'll have the minus 4xy squared, our first copy, and then we'll have the minus 4xy squared, our second copy, and then for product rule, we put a plus sign in the middle, and then we apply the derivative in the first copy to the first term, and then in the second copy, we apply the derivative to the second term there, the y squared. All right. So far, we've done our product rule on the first term, and we've done our product rule on the second term. All right, so let's finish differentiating the easy ones. So let's get this minus 5x. So derivative of minus 5x is just going to be minus 5, and then derivative of 8 is just going to be 0. All right, so now we still have some derivatives to do, so let's finish these off. So derivative of 6x squared, we do our power rule. Take the 2, bring it down, multiply it with the 6. So we get 12x. And then the y cubed plus 6x squared is outside the brackets, so we're done with those. Now here, we're going to differentiate a y term. So we start by doing our regular power rule. So bring down the 3, put it in front of the y, subtract 1. But because we also differentiated a y term here, we're going to multiply that result by y prime. Okay. So then, let's go on to our next set. So what's the derivative of negative 4x? Well, it's going to be negative 4. So we'll have negative 4y squared. Then we've got our negative 4x. And while you're at it now that we're kind of remembering the negative, the plus with the minus sign here, we can just think of that as subtraction. And then let's differentiate this y squared term. So do our power rule. We end up with 2y. And then let's multiply that by y prime, because we're differentiating y term. All right. So we're done differentiating. But now we need to solve for y prime. So you want to scan through your equation. We've got this whole big equation now. We're done with the derivative part, but we need to solve for y prime. So scan through, and any term that has a y prime in it, we've got a few of these, we want to keep on the left-hand side of our equation. Anything that doesn't have a y prime in it, so we've got a few of these, we want to move to the right-hand side of our equation. So we're going to move the 12xy cubed. So let's get that to the other side. This is being added in. So the way we move something to the other side is with subtraction when we're kind of undoing an addition. And this term is being subtracted, so the way we move that to the other side is by adding that to both sides of our equation. And then same thing with the 5. We're going to add that to both sides. All right, so what do we have? What do we have so far? So we didn't do anything with these. We're leaving these where they are. And while we're at it, let's just clean these up a little bit. So we have a 3 here and a 6 here. We can multiply those constants together and just kind of group them all together. So 6 times 3 is 18. And then we've got an x squared, a y squared, and a y prime. So let's get those. I always like to write the y prime at the end there. And then let's simplify this one kind of similar. So we've got a negative 4 and a 2. So let's multiply those together. We get negative 8. And then we've got an x, a y, and a y prime. So x, y, and then times y prime. All right. So then what do we have on the other side of our equation? Well, we've got all the terms that we moved over. So we've got the negative 12xy cubed. We've got the positive 4y squared, and then positive 5. So we've got all those terms we've moved over. All right. So we're not done. We want to isolate y prime. So now the step is we're going to factor out. So now everything on this left-hand side of our equation is guaranteed, if we did it correctly, is guaranteed to have a single copy of y prime in it. So what we can do is from each of those terms, we can factor out a y prime. So if we do that, we're going to get y prime out of there. And just imagine, what do you have left after you factor out the y prime? Well, if we get rid of the y prime from that first term, just cancel it out, factor it out, what do you have left? Well, you have this piece. So we're going to have 18 x squared y squared. And then let's factor out the y prime from here. So what are we going to have left there? Well, just the minus 8xy. Okay. And then we're not doing anything to the other side of our equation. So that's all going to stay the same. And once we've factored out that y prime, the only thing left to do then is take all this stuff, and we just need to move it to the other side of our equation. Now, Whereas before, the way we moved stuff around was with addition or subtraction. Now, this is being multiplied. This is multiplying y prime. So the way you undo that multiplication is with division. So we're going to divide by all this stuff. And when we do that, let's see what we get. And that'll just give us y prime. So we're going to divide. And that'll leave us with just y prime on the one side of our equation. And we'll have the negative 12xy cubed plus 4y squared plus 5. That's going to be our numerator. And then in our denominator is going to be all this stuff. So 18x squared y squared minus 8xy. And that's it. That's our derivative. And if you wanted to, as you're doing these implicits, I like using y prime, but sometimes the primes get a little, they start to look like ones. So if you want to, when you're doing implicit differentiation, instead of writing the y primes here, it's the same thing as dy dx. All right. So let's stop there. We'll try a few more examples of these in class. And then we'll also be starting to look at, well, an application of implicit differentiation called related rates. So we'll see you then. Bye-bye.